On December 15, 2020, the MC-21-310 airliner took off from the airfield of the Irkutsk aircraft plant. At first glance, nothing special, no stunts, extremes, and records. But this particular flight can be considered crucial, because for the first time, an airliner was raised into the sky by fiery hots, the very existence of which for a long time was considered an unattainable goal. Hello aviators, Sky here, and today we will get acquainted with the first completely new Russian civil aircraft engine in several decades, find out what solutions and technologies it has incorporated into itself, and how it pulls forward not only the aircraft, but the entire industry. I present to you the PD-14. Despite the fact that the PD-14 started flying recently, its history is quite long and full of adventures. In the late 2000s, the SSJ-100 airliner entered the home stretch before the start of deliveries. A completely new modern regional jet, ambitious but without extremes. However, progress is necessary, and having created the superjet, the aviators decided to make a medium-hull jet and enter the market with the largest volumes, which has long been ruled by the Boeing 737 and Airbus A320. Moreover, they had to fight for this market with their new generation, and the MAX and NEO are Goliaths, the main trump cards of which were the latest aircraft engines. The future MC-21 airliner was supposed to be a huge leap forward, and the engine issue was one of the most important. The bar is clear, the power plant must be at least at the level of competitors, otherwise no matter what the plane is, no one will need it. The first and most obvious decision was to install the same engines as the competitors. And it was accepted. The MC-21 is offered with a Pratt & Whitney motor, one of the leaders. However, at the dawn of the program in 2008, the newly formed United Engine Corporation, UEC, proposed another road that the aviators decided to take, to create another engine, a Russian one. In the beginning, this decision seemed like a gamble. The engine that had to be created had no right to be inferior to counterparts, and the counterparts, the most advanced motors in the world, are the results of decades of evolution within the walls of huge corporations. There are only a few of them in the world. It seemed that the Russian engine-building industry, which had been in a semi-comatose state for a long time, simply wouldn't catch up with them. While the world giants of the industry had to take 3 steps, the UEC would have to take 10. But the project nevertheless was launched. Considering that the engines are intended primarily for the MC-21 family, which includes several airliners of different dimensions, the thrust of the engines for them ranged from approximately 123 to 153 kilonewtons. The promising engine, in Russian Perspektivny двигатель, with a thrust of 137 kilonewtons or 14 tons force, was supposed to become the base one, and this is how the name PD-14 appeared. And now a cold shower. I will not be telling the success stories of a team of lively adventurers, just as I will not be throwing loud phrases about an incredibly breakthrough of an unparalleled mega device, from one side of which desperate competitors panicked and closed. The creators of the PD-14 soberly assessed the opportunities, problems, and risks. Yes, the accumulated potential is very large, but the lack in a number of technologies is large too, and it needs to be fixed, moreover, in a short time. The best is the enemy of good. No one will wait 20 years for an epic and ahead of its time museum exhibit that never made it to the series as unnecessary. So, the task was clear. The PD-14 has to be a modern, efficient, environmentally friendly, and competitive engine. No more and no less. You can't lag behind, but you can't chase incredible innovations and wow effects either. I repeat, the UEC needs to take 10 steps, and any unnecessary risks could kill the project in the bud. Even with a conservative approach, the PD-14 is supposed to be one of the top engines in its class, and a very serious challenge. We're not talking about modifying something that already exists, but about a completely new engine that incorporates both the best solutions available and a lot of completely new technologies that have not been previously used at all. Russian engineers have not had tests of this scale since the 1980s. Once the program was initiated, the entire industry got involved. The UEC Aviadvigatel became the head design bureau. Related work was deployed throughout the country, including both university labs and giant aviation centers, such as Tsagi, Viam, and Tsiam. All aspects were worked out, from aerodynamics and computer modeling to mechanization and materials. At the same time, production workers got down to business. The components of the new engines are being manufactured at many sites, and the main one among them, the place where the finished engines will be born, is the UEC Perm Motors plant. All of them faced a serious modernization. The corporation was reformed, the reconstruction of facilities began, centers of competence, new production facilities, and laboratories were created. Personnel was retrained, and the latest equipment was purchased. Thousands of machine tools, robots, and entire platforms. The PD-14 managed to push the whole Russian aviation engines industry forward, even before it lifted the plane for which it was created. Nevertheless, despite the complexity of the tasks set, the work was carried out actively and quickly. Already in 2012, the first prototype for ground tests was assembled, and in subsequent years it was joined by more and more prototype brothers. In 2015, the engine saw the sky from under the wing of the Il-76 flying lab. The main stage of testing was carried out on it, which ended in 2018 with a certificate from the Russian aviation authorities. After that, the PD-14 went under the very wing it was created for. The airliner in the basic configuration with the PD-14 engine received the MC-21-310 index, and finally, in December 2020, took to the skies. At the initial stage of testing, pilots behaved more carefully with the engine, but rather quickly they began to push it to the limit, and the PD-14 showed itself quite decently, without limiting them in any way. The MC-21-310 conducts dozens of tests, participates in demonstration flights, and flies over long distances, including outside of Russia. The Dubai Air Show was the airliner's first overseas tour, and there were no particular issues with the engine's operation. But the tests continue too, and at times with curious stages. Recently there was a test for the reliability of the power plant in flight conditions in clouds of volcanic ash. Previously, no one was particularly interested in such situations, but a volcano erupted in Iceland which closed the airspace of a half of Europe. And while the whole world was trying to pronounce the name Eyjafjallajökull, the aviation authorities thought about flight safety. The test became a non-trivial task. At the stands, the aviators drove through the engine, real ash of Kamchatka volcanoes, checking its ability to function in such conditions. And this work was new not only for Russia. New requirements and such tests had not been carried out on a large scale before. And so, let's figure out what this whole industrial dance revolves around. The PD-14 is a classic modern turbojet engine. The airflow in it moves along two circuits. In the core, the air is compressed, ignited, rotates the turbine, and is thrown out through the nozzle, creating thrust. The bypass duct starts with a large fan, which we can see from the outside. The fan spins, forcing air through the circuit, creating additional thrust and increasing engine efficiency. Now in more detail. Let's start describing the engine from the inside out. The core is the heart of the engine, its hot part. It is thanks to it that the jet engines are called fiery hots, for they are fiery in the literal sense. The PD-14 is a 5th generation engine, not to be confused with the famous 5th generation of fighters. No one expects these engines to have stealth, supersonic cruise, super maneuverability, and all that. One of the main parameters characterizing the generations of jet engines is the temperature of gas coming to the turbine from the combustion chamber. Efficiency depends on it to a decent extent. The early engines that appeared at the end of the Second World War could heat up to 900 degrees Celsius, and over time, by the 5th generation, this bar actually doubled. Meanwhile, the ability to work in this mode for a long time also grew. The The first engines were terribly unreliable, dirty, and noisy, and their resource was often at the level of "you can fly a little." Modern engines must run for a very long time, be economical and environmentally friendly. A balance must be struck between, in fact, opposite parameters. No one needs a super powerful but disposable engine, just like a super reliable mechanism that is unable to lift an aircraft into the air. In the front part there is a compressor, the task of which is to compress the air passing through it. It is driven forward by stages, rotating disc structures of complex shapes with blades along the circumference, kind of unusual fans. There are as many as 11 of them, 3 low pressure and 8 high pressure stages, and as it moves through the engine, the number of their blades increases, and the volume through which the air passes decreases, like a gorge through which a river flows. Cozy descriptions should not deceive you. This is a roaring machine with discs spinning at breakneck speeds, inside which air in a split second turns from a cool breeze into hot gas, the pressure of which jumps 40 times. Following the compressor is the main hero of this fire show, a low-emission combustion chamber, where fuel is injected into the gas and ignited, heating it to almost 2000 degrees. The chamber by itself is a work of art. The design, with a very clever flow configuration which includes 48 nozzles, is so complex to build that additive manufacturing is used for this work. Yes, some of the parts are printed from metal by 3D printers. This is not just a desire to simplify production, and not a tribute to industrial fashion. Otherwise, it is simply impossible to make such a mechanism with the required parameters of compactness, reliability, and efficiency. In the turbine, the process is, in a sense, the reverse to the process in the compressor. Now, hot and compressed air is bursting through the mechanism, rushing first into 2 high-pressure stages and then into 6 low-pressure stages. Now the gas rotates the turbine, and part of its energy is transmitted through it to the shaft, which rotates the fan and the compressor blades, which in turn compress and drive the gas here. Such is the circulation of energies in the engine. The hot gas that passed through the turbine roars out of the nozzle, creating jet thrust. The main challenge for engine builders in a core are structural elements in direct contact with the working area, primarily the blades. They must be able to withstand enormous loads without melting or collapsing. There are several solutions to this problem. Specially created high-temperature alloys from which the casings are made. I will not describe the composition, it has half of the periodic table. Inside of these casings there are special channels through which air passes, cooling them from the inside. As a dessert, there's a special ceramic coating that takes the first blow of heat, something like ceramic tiles that protect spaceships when entering the Earth's atmosphere. These solutions in various combinations allow the blades to work normally. Each blade, and there are hundreds of them here. So, we examined the core of our fiery heart. Now it's time to step back a little and look at the bypass duct. Everything is simpler here. There is no combustion chamber, there is no turbine, there is only one fan. But it's a big one. The description of the bypass stream of the PD-14 raises a number of questions and often becomes the cause of criticism of the engine as a whole. 3 features raise questions. The fan of the engine is titanium. It has a diameter of 1900 mm, 190 cm. Behind the fan is the main part of the engine, the bypass ratio of which is 8.5. This means that in the PD-14, 8.5 times more air is driven through the bypass duct than through the core. For modern turbofans, an important parameter that engine builders like to point out. And then there's a question. Fans of the competing 5th generation engines are composite and more big, with the larger bypass ratios ranging from the impressive 11 to a wild 12.5. So what's up? These parameters cannot be considered in isolation from the rest, both in the engine itself and in conjunction with the aircraft. The MC-21 introduces a number of requirements for the PD-14, which was created for it. A large fan and a high bypass ratio are good, but they increase the size and weight of the motor as well as air resistance. Besides, a huge bypass ratio is achieved through the use of special solutions and components that complicated the engines and created a number of problems that gave both manufacturers and operators a lot of headache during the initial stage of operation. UEC, in the struggle for the optimal design, decided not to complicate things, and the performance is still very high. For example, in the engines of the 4th generation in this class, the bypass ratio is at the level of 5 to 6. And the second question. The fan of the PD-14 is composed of a group of wide-cored, hollow titanium blades. In the Russian engine building, this technology has not been massively used before, and is being mastered right now. Unlike the conventional metal blades that can be seen on most aircraft engines, the new blades are lighter, larger, have a complex aerodynamic shape, and do not require additional reinforcing elements. Yes, they are still a little heavier than composite ones, but here, again, the question of balance is raised. Composite blades are quite complex and expensive to manufacture, and the weight advantage becomes decisive as their size increases. For example, it is pointless to put composite fans on small motors. You get the same thing for a bigger price. And conversely, on large engines, composite fans are practically the only option. The metal here will be too heavy. The 75-inch PD-14 fan is an adjacent point, at which composites and metals are approximately equal. The engineers evaluated pros and cons and chose hollow titanium as a more optimal option that can be mastered within the required time frame. In addition, the Russian metal industry is rich in both titanium itself and experience in working with it, including the creation of components for aircraft systems, and it is easier and cheaper to purchase from your own. It would be strange not to take advantage of such a bonus. One more reason, after mastering the PD-14, the small PD-8 will be created, which certainly requires a titanium fan, and the already mastered technology greatly simplifies the work. The composite blades of large size for Russia are a fairly new technology. For competitors in this regard, it is easier. But you shouldn't think that they are not engaged in them. Prototypes are being created, tested, and will be installed on engines, first of all on the promising large PD-35. And with the development of this technology, within the framework of certain modernizations, the solution may well spread, among others, to the PD-14, if it is really necessary. How did this affect the engine? The PD-14 surpasses its predecessors in specific fuel consumption by 12 to 16% and in emissions by about 30%. Further, more interesting. Conservatism in the design and a lesser bypass ratio gave both pros and cons, moreover with nuances. The PD-14 probably has a higher specific fuel consumption, but due to the better aerodynamics of the aircraft, it can maintain the required flight speed with less thrust, which reduces consumption. So, in cruising mode, it is close to colleagues in class, slightly falling behind them at low speeds, for example on the ground, on takeoffs and landings. In addition, if oil becomes cheaper, the slightly higher fuel consumption won't matter. This is quite realistic, given the trend of decreasing demand for fossil fuels, and the engines are created for decades to come. At the same time, conservatism gives advantages. Proven solutions, better reliability, cheaper elements, and production. The engine itself will be cheaper, both in purchase and in operation. This should keep the PD-14, considering all the parameters, at the level of counterparts. And all this had to be calculated in advance, along with a million other parameters, even before the engine itself was created. This is what you call experience and competence. Now we're gonna look at the labyrinth of devices, cables, pipes, pumps, and sensors wrapped around the engine. Usually this isn't talked about much, because go figure what all this means. But without all this conglomeration, any aircraft engine is just a beautiful art installation. For a part of this system, automation, UEC STAR is responsible. STAR is not really a name as it might seem, but an abbreviation. Системы топливного питания и автоматического регулирования, or Fuel Supply and Automatic Regulation Systems. Unlike the engine bodies, their brains have their own generations. For example, early motors were driven by hydraulics, which were only helped by electronics. The 4th generation acquired more complex systems, such as FEDEC, which were fully responsible for the operation of the engine, and the mechanic was already in secondary roles. The 5th generation uses serious computers with complex software functionality that controls all processes. There are practically no mechanics here. In addition, new materials and technologies are actively used here: lighter alloys, high-temperature mechanisms, additive manufacturing, and immediately with them, bionic design. A new area that allows you to design parts with excellent characteristics and, in some places, unusual appearance. Soon the engine units will look like they were painted by Alien's father, H.R. Geiger, but it should be cool at work. So far the engines don't look like alien artifacts, but progress is evident. For example, here's the electronic regulator of the PS-90 engine, which can be seen under the wings of many Russian aircraft. Next to it is the brother, the PD-14 regulator, a little lighter and much more compact with wider functionality. This is felt even more clearly in the example of regulator pumps that supply fuel in the engine. If this thing does not impress you, let me tell you one figure. The PS-90A hydromechanical regulator consists of 6,489 parts. A similar unit at the PD-14 is built on the basis of electronic regulators. There are only about 1,200 parts, several times less. This makes the regulator more simple, compact, light, and reliable. The fuel unit has a resource of 20,000 hours, and the rest of the units 40,000. Such figures have never been reached by Russian engine builders before. To achieve these indicators, stringent tests are carried out. Absolutely all components are tested. Moreover, not only for normal operation, but also in rather harsh conditions. They are shaken on vibration stands, flooded, frozen, and on the contrary overheated. The electronic unit was actually burned on the stand, while the engineers heartlessly watched how the decaying computer behaves and whether it transmits inadequate commands to the engine. Curiously, the element base of the engine is almost entirely Russian. The motives are purely practical. Firstly, no one wants to breed competitors, so critical technologies do not leave the walls of manufacturers. Secondly, it can be difficult to work with large suppliers. If the volumes of contracts are small, they are not taken seriously. Domestic companies, one way or another, manage to organize production of the element base. And with the localization of supplies, trade wars and the crisis of logistics and electronics driving entire industries into a coma, bypasses the engine builders. Finally, we can look at the engine as it appears to ordinary passengers. The PD-14 nacelle, covering the mechanisms and providing aerodynamic flow, is made of composite materials and is also created in a division of UEC Aviadvigatel. For all the external simplicity, the structure is very complex, especially considering the aerodynamic component, airflow, and interaction with the pylon and the wing. An error here can seriously impair the performance of the airframe. Naturally, the engine is equipped with a thrust reverser. This is a special mechanism that, at the moment of landing, turns the airflow around and slows down the aircraft. These mechanisms are diverse, and on the PD-14, a sliding version is installed. When a part of the nacelle fairing is displaced slightly backward, inside, the blades blocking the flow move out and the air rushes forward. On the PD-14, the mechanism is lightweight, made of composites, and is powered by electronic drives. This has not been done in Russia before. Another external element of the engine is the chevrons. The sawtooth end of the circuit ensures smooth mixing of airflows, which reduces the level of noise resulting from it. Quite a fashionable solution. The PD-14 previously assumed the installation of chevrons on both circuits, and they were even tested, but over time the outer one was removed from the second circuit. The engine was originally designed in a way to minimize noise, and this turned out to be enough to meet modern and future requirements. An external chevron was not needed, and no one wanted to install a complex structure just for beauty. On the nozzle, however, the chevron remained, and now flies. The PD-14 is being created for the MC-21 airliner, but thanks to the gigantic volume of developed technologies and the overclocking of the entire industry, there is no doubt that it will not be alone for long. The basic PD-14 develops a thrust of up to 137 kilonewtons and will be installed on the basic MC-21. The heavier version of the airliner will receive the forced PD-14M engine with a thrust of 153 kilonewtons. In addition, the use of proven technologies and solutions makes it possible to create other engines, first of which will be the smaller PD-8 with a thrust of 77.5 kilonewtons for the updated Superjet. And of course the PD-35 with a thrust of 343 kilonewtons, which is being created for heavy aircraft, primarily wide-body airliners. Magnum opus of the UEC. Nothing like this has ever been created, either in Russia or the USSR. The PD-35 program is actively developing, large-scale research is underway, and some units are already being tested. Plus, Perm Motors, being the largest developer and manufacturer of power plants for the energy industry, having created the PD-14, could not say no to the idea of making its ground version. It became the PD-14 GP1 and 2, industrial power plants for power stations and gas transmission units with a capacity of 12 and 16 megawatts in 2 versions, which will be 8% more economical than their predecessors and much better in terms of ecology. And they are very much awaited. The forecast demand for these power plants until 2031 is about 210 units. The re-equipment and modernization of production, started together with the PD-14 program, continues to this day, and its scale is very serious. Even now many sites continue to receive equipment, so it shouldn't come as a surprise that in the workshops, continuously operating machines stand next to huge boxes with their not yet unpacked relatives. For example, in Perm, a competence center is being created for the production of engine shafts, the very parts holding the entire circuit, and the requirements for quality and accuracy are very high here. The plans to increase the output are very serious, while now 300 of them are being made per year. After the full launch of the entire line, 1,500 units will be coming from here annually. The same thing is happening with advanced production facilities, which, in fact, are created from scratch. The same 3D printing from local solutions for some parts is growing into full-fledged centers of additive manufacturing. And such a picture can be seen at many objects of the UEC and Rostech throughout Russia. A multi-fold increase in production volumes over the next few years here are quite normal and realistic plans. Another subtle factor that is no less important than any other is after-sales support. Nobody will want even the best plane in the world if after every minor breakdown it will spend weeks in repair, waiting for a spare part. The creators of the MC-21 and PD-14 understand this perfectly well, and given that the advantage of the new engine is the low cost of the life cycle, this factor becomes critically important, so the service infrastructure is being created right now. As part of the UEC, repair sites and training centers are being created, starting directly with Perm Motors and further in the required regions. Large-scale work is underway to organize logistics, pools of replacement engines, spare parts, and all other support elements. The basic infrastructure should be ready by the time the first PD-14 under the wing of the MC-21-310 arrives to the first operator. Further plans are variable and will be implemented depending on demand. By the end of 2021, Perm Motors assembled almost the entire testing batch of engines, the earliest of which were sent to the test sites, and the new ones are already flying on the MC-21. With the launch of serial production, the output will increase. The potential is quite large. Here a lot depends on the engine builders and on the aircraft themselves, the rates of their production and deliveries. Let's hope that everything goes as it should, and soon we will see hundreds of representatives of the family of fiery hearts, whose father was the PD-14. Enzo Ferrari once said, "I don't sell cars, I sell engines. The cars I throw in for free since something has to hold the engine in." I don't think the MC-21 will be given away for free, but its most important part is the engines, ready for the great and glorious era of travel in the skies of this blue ball. Many thanks to the guys at the United Engine Corporation for their help in creating this story. And you aviation fans fly good planes with good engines. And if you want to watch the videos early, see some exclusive behind-the-scenes content, or just support the channel, consider joining our Patreon community. Fast flights and soft landings to you.